we'll discuss about structure of pyrrole, furan and thiophene along with their molecular orbital picture diagrams. Pyrrole C4H5N, furan C4H4O, thiophene C4H4S. All the three are having 4 sp2 hybrid carbons, and the heteroatom nitrogen here, oxygen in furan and sulfur in thiophene also are sp2 hybridized. About the ground state configuration of these elements, nitrogen is having 1s2, 2s2, 2px1, 2py1, 2pz1 configuration, oxygen 1s2, 2s2, 2px2, 2py1, 2pz1, sulfur 1s2, 2s2, 2p6, 3s2, 3px2, 3py1, 3pz1, and carbon 1s2, 2s2, 2px1, 2py1, 2pz0. After sp2 hybridization, carbon has got 3 sp2 hybrid orbitals having 1 electron each, and unhybridized orbital also having 1 electron in it. In case of nitrogen, it has 3 sp2 hybrid orbitals having 1 electron each, and unhybridized orbital having a pair of electron. Oxygen has got 3 sp2 hybrid orbitals, out of which 2 have got 1 electron, and third sp2 hybrid orbital has a pair of electron. The unhybridized p orbital also has got a pair of electrons. Sulfur has got 3 sp2 hybrid orbitals. Like oxygen, 2 of the hybrid orbitals have got 1 electron, and third has got a pair of electron. The unhybridized p orbital of sulfur has also got 2 electrons. In all the 3 heterocyclics, the 3 sp2 hybrid orbitals of 4 carbons, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, all these are involved in formation of CC, CH, CN, CC, CH, CN bonds. This is CH, CC bonds, CH, CC bonds. These are CH bonds. In case of pyrrole, CC, CH and CN bonds. Pyrrole, CC, CH and CN bonds. And in case of furan, there are CC, CH and CO bonds. That is CC, CH and CO bonds. And In case of thiophene, these are CC, CH and CS bonds. This is thiophene, and in this CC, 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 CH, 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 CH and CS, CS bonds. The three sp2 hybrid orbitals of nitrogen having one electron each in them are involved in forming 2C2N, 2C2N bonds and one NH bond. One NH bond. Out of the three sp2 hybrid orbitals of oxygen, two having one electron are used in forming two CO bonds, and one sp2 hybrid orbital having two electrons is having unshared pair of electron. One sp2 hybrid orbital forming bond with carbon, other also forming bond with carbon, third one is having unshared pair of electron in it. Now the four carbons having one electron unhybridized p orbital with one electron each and the two electrons in unhybridized p orbitals of each heteroatom, nitrogen in case of Pyrole, oxygen in case of Furan and sulfur in case of Thiophene, they form pi electron cloud of 6 electrons, which is according to 4n plus 2 pi electron system, according to Huckel's rules, making all these three heterocyclics aromatic in character. All the three are planar and are stabilized by resonance to the extent, in case of Pyrole, resonance energy is 100 kilojoule per mole. In case of Furan, resonance energy is 65 kilojoule per mole. In case of Thiophene, it is 125 kilojoule per mole. In comparison to benzene, which is stabilized by 151 kilojoule per mole, and conjugated dienes, which are stabilized up to 12.5 kilojoule per mole, all these make these three heterocyclics aromatic in character. Now about resonating structures of Pyrole, we can see 1, 2, 3, 4, 5 resonating structures. Out of these 5, 4 having charge separation in them, positive charge on nitrogen, negative here, positive, negative, positive, negative, positive, negative. All these 4 are having charge separation. The only one structure, this will be most stable and will be contributing most toward resonance. Its resonating structure its resonance hybrid can be represented like this, a circle which is showing the delocalized pi electron cloud. It is 6 pi electron cloud represented by this circle. In case of Furan, here also 1, 2, 3, 4, 5 resonating structures. Here also 4 are having charge separation in them, positive, negative, positive, negative, positive, negative, positive, negative. Thiophene also having 5 resonating structures. 4 out of 5, these are involving charge separation in them. The 3 heterocyclics, we can see here pi electron clouds above and below the plane of the ring, above the plane, below the plane, and studying about relative aromatic character of Pyrole, Furan and Thiophene. Each of 3 compounds consists of flat ring of 4 carbon and 1 heteroatom with a cyclic electron cloud of 6 pi electrons, which is in keeping with Huckel's rule. Thus, all these compounds exhibit aromatic character. It may be noted that number 1, of the 5 contributing structures of each of these heterocyclics, 3 heterocyclics, there is one structure in each case which does not involve charge separation. That is this structure here in Thiophene, this structure in Furan, this structure in Pyrole, and this structure makes major contribution to the resonance hybrid. As against this, both the contributing structures of benzene, are uncharged and equally stable. As a result, the resonance energies of these heterocyclics are lesser than that of benzene, because here 2 structures are contributing equally. Here in these 3 cases only one structure is having major contribution. Now to compare the aromaticity among the 3 heterocyclics, Thiophene is most stabilized, means its resonance energy is 125 kJ per mole, as compared to Furan, whose resonance energy is 100 kJ per mole and 65 kJ per mole, and Pyrole, which is having 100 kJ per mole of resonance energy. Reason for this is the electronegativities of heteroatoms. Oxygen is most electronegative, than nitrogen, than sulfur. So oxygen has least tendency to release electron towards delocalized pi electron cloud. Consequently, Furan is least aromatic. Pyrole has greater aromaticity. And Thiophene has greatest, that is, Thiophene is having 125 kilojoule per mole, resonance stabilized by this much amount of energy. Pyrole by 100 kilojoule per mole and Furan by 65 kilojoule per mole of energy. Hence we can say Thiophene is more stabilized by resonance than Pyrole and then Furan.